Hey, we're Go Math Lesson 8.3, and today we're talking about modeling equations through pictures. We're going to be using what are called algebra tiles, which are kind of like a base 10, but a little bit different. Now, when you're solving this in class, there's very little requirement for me to force you to do algebra tiles. If you understand it in a different way, I'm totally okay with that. I want to show you the algebra tiles, though, because some of us are visual people. We really like to see them. So if I had something, for example, this is going to represent x. That's the number I don't know yet, right? This is going to represent 1. So if I had something along the lines of x plus 2 equals 5, I would write it in algebra tiles like this. X plus 2 equals 5. So I have x plus 2 equals 5. Now, why would I do this? Because, again, our visual learners, we like to see these models, and now I can manipulate them to solve for x. So what I end up with, again, if I was looking at this as a scale, an equal sign being my little balance point here, I can take something off of both of them. I'm going to erase this one and this one, which means I can also take away this one and this one. Now, what am I left with on this side? I'm left with x. And on this side, I'm left with 1, 2, 3. X equals 3. If you want to see it without the algebra tiles, you would say x plus 2 equals 5. Instead of adding 2, I can take 2 from both sides, and I'm left with x on this side and 3 on that side. If this makes sense to you and you want to do it this way, and you don't want to do it this way, I'm okay with that. If you like doing it this way because that really makes sense, and some of us are like that, and you want to do it this way, fine. I'm good either way. So let's see what it looks like in your book. It goes something like this. You can solve an equation by drawing a model to represent algebra tiles. Let a rectangle represent the variable, we already know that, and let a small square represent 1. Solve the equation x plus 3 equals 7. Well, let's make that a little bigger. I need an actual rectangle. No need to be skimpy with our rectangle drawing. X plus 3 equals 3, 4, 5, 6, 7. X plus 3 equals 7. I want to solve for x, so I can cross off 1, 2, 3. 1, 2, 3. And I'm left with x equals 4. Once again, on this side, I'm looking at x plus 3 equals 7. I can't take x's off of either side because I don't have x's on both sides, but I can take 3 away from both sides. Subtract 3, subtract 3. I get left with x and 4. Now, I can go back and double check my work, and we always tell you, please go back and double check your work, and you never do because you think, well, I have to redo everything again. That's not true. If x equals 4, ask yourself, does 4 plus 3 equal 7? Yes, you checked your work. It's that simple. Again, how'd you do on your math test? Well, if you did that, you did pretty well. You understood what you were talking about. If you just kind of went through and, I don't know, I guess I drew some boxes and that made sense, you may not do as well as you could have. So take your time, write out all of your work. Let's take a look at one more here. There we go. 3 plus x equals 4. Yes, and I know some of you are looking at this going, wow, 3 plus some number equals 4. I can do this in my head. Why do I have to do this? They're not always going to be this easy. They do get a little bit more complex. So we have 3 plus x equals 4. Start with the equation. Start with the equation. Start with the equation. 1, 2, 3 plus x equals 1, 2, 3, 4. And when I cross off my 3 from this side and 3 from this side, I'm left with x. Again, don't get skimpy with the rectangle. X equals 1. So x equals 1. And if you wanted to do it without drawing, subtract your 3, subtract your 3. I'm left with x equals 1. Okay? So again, when you're balancing this and you want to show your work, you can show it as tiles, algebra tiles. So make a rectangle for x, and each one will be those little squares, right? draw out your number of squares, and then you can pull them away from both sides so that you're left with just the solution to x. And if you would rather, there we go. All right, well, if you would rather, you can just write it out as the 3 plus x equals 4, and then realize what you can take off of each side.